Hello everyone, and welcome to another Linux tutorial. If you would like maximum hardware accelerated performance from your virtual machines for work or gaming, this video might be for you. We'll dive into the world of QEMU, libvirt, and virt-manager right after this. For about a year now, I've been daily driving Fedora Workstation for much of my production, and have recently migrated to the RPM OS tree-based Silverblue edition as a secure, immutable base for hosting projects, experiments, and demonstrations. The steps I show here should translate readily if you're running a different Linux distro and are willing to do a small bit of research. Let's begin this tutorial by booting up a Fedora Silverblue box and get to work. Here's a pretty standard, fully updated Fedora Silverblue installation. So let's launch a terminal here and do an rpm-os tree status to make sure that there are no updates happening in the background. And it's idle, that's good, we can continue. The only layered package we have here is langpax en, or English language package. That's standard default layer for a standard Fedora Silverblue install. The networking is working fine. We've got a secure local IP address configured, so we can proceed. Let's install the goods here with rpm-os tree install virt-install libvirt-daemon-config-network libvirt-daemon-kvm QEMU-kvm virt-manager. We'll be using a bunch of that later on in this video. virt-viewer, guest file system -tools, and libguest file system -tools. Python 3-libguest fs for file system. virt-top, libvirt-devel, bridge-utils, and for the UEFI ROMs, we want edk2-ovmf, so for a UEFI-based virtual machine. So that's a full package list for pretty much anything you want to do with kvm libvirt. So I put all those in there for completion. Okay, we'll let it do its thing. And now all we need to do for this Silverblue install is reboot to have the RPM package install happen on our immutable image. Okay, let's log in. And we are back. So let's open up the terminal, make it full screen, and let's do another RPM OS tree status. And now you can see with our latest pin deployment, it's idle, that's good. We've got a whole bunch of new layered packages that we just performed. So all these packages are installed or layered on top of the image in addition to the English language pack. Your location may, of course, be different for your different languages. Okay, good. So we're ready to go. Let's become root here. And next, let's go ahead and clear the terminal and check for processor hardware virtualization acceleration. So we do cat proc CPU info. We pipe it to enhanced grep. And we're looking for VMX for AMD, or Intel rather, or SVM flag for AMD processors. We're running on an AMD processor today, so SVM flag, processor flag is there, which means we're ready for KVM hardware virtualization. So let's do a systemctl enable now or immediately libvirt as the basic service for libvirt and all its tools and utilities. So let's check the status. As you can see, the virtualization daemon is now running and enabled, and it created a nice virtualized network with DHCP and using DNS mask. So it looks like we are ready to continue. So let's clear the screen. Let's do an lsmod and pipe it to grep kernel virtualization module or KVM module. And we've got the KVM_AMD for our AMD processor loaded and ready to go. So far, so good. So let's do a check on what's in var lib libvirt. And here we can see that we have our directories already set up. Boot, that's where our ISO images will go. And then also images, and that's where our virtual machine hard disk images go. These are all these will be copy on write images, both ISO and the virtual machine hard drives. So we will need to, with lsattr, check and see if the copy run write is turned off, because we get hangs and performance issues if we don't do this. So it's not turned off yet. We don't see a C here in boot and images directories. That'll be fixed automatically when we set up the storage pools, the two storage pools. So let's go ahead and take care of that now. So virsh pool -list -all shows we have no pools, storage pools configured yet. So let's take care of it. Let's do first virsh pool -define -as -name, and we'll call it in quotes because there's space in there, disk images, and then close quotes, and --type, dir for directory, --target, we put /var libvirt images, and those will be our virtual machine disk images for like the hard drives, right? Okay, that's done. Next, we'll do an up arrow, history, so we don't do so much typing, and we'll define another pool for our ISO images. We'll call that pool installation media. Those are for our ISO files. We can put them in there. We'll put that in the boot directory. All right. Pool installation media defined. All right. We'll be using those two pools going forward in this video. That's good enough for most people's use, at least for me. You can see the status inactive and no auto start, so let's fix that. Let's activate with virsh pool -start -build, and we'll take care of the disk images pool. So that should be started. And then the installation media, we'll do the same thing with pool start and build. So that's done. Let's check the pool list. As you can see, we have both our pools active, but still not auto-started. For convenience, I like to auto-start both of them. So to do that, what I just can simply do is virsh, for virtual shell, by the way, pool-autostart, in quotes, disk images, hit return. So now it's marked as auto-started for disk image pool, and then we'll do the same thing for the installation media pool. Like so. Very simple. Okay. Now, our pool list shows both as active states and auto start equals yes. All right, so you can also get more info from your pools by just issuing the command virsh-pool-info. Disk images, for example, shows this. So we have 120 gigs for virtual machines. And it's shared with the installation media pool. It's the same disk, right? The same physical disk. So that's shared with our ISO storage under installation media in the boot subdirectory. So let's check that copy and write is turned off for boot and images by typing ls-attr for list attributes. And we can see for both the ISO directory, boot, copy and write is turned off, and images for our virtual machine hard drives. That directory also has copy and write turned off. So we don't have hangs because we don't want to run copy and write images on top of our BTRFS copy and write host system. So that's good. That's taken care of automatically to make sure our machines don't hang. So let's check the security here. See how our security is configured for the host and for the future virtual machines that we'll set up. So I'll type nano etc libvirt qemu.conf. I can't talk today. So I'm going to look for the setting search security_driver. So the default security driver is SELinux. And that's how Silverblue is set up conveniently. As you can see here, security driver is SELinux. It's commented out because it's the default, and we'll leave it that way. So the basic security protects the host from any rogue virtual machines. So we can check to make sure SELinux is enabled on the all the images in our directories by typing ls-dz, lowercase d, capital Z, var libvirt images. That's for our virtual machine locations. So you can see virt-image_t is defined, so SELinux is enabled. So that's secure under SELinux. And we'll check boot quickly for the ISO images. And virt-content for our ISO images is defined. So that's good. So SELinux is working on a basic level. All right. So we can proceed by configuring a virtual machine. So let's go ahead and let me make this a little smaller here. Let me launch Fedora Media Writer. So here we can download some example ISOs from Fedora. Under emerging editions, you can download Fedora Silverblue or Kinoite. So I've done that already to help save you some time and make this tutorial a little shorter. It downloads the latest ISOs into the downloads directory. So let's change directory. Post, let's pretend we've already run Fedora Media Writer already. So we've got the ISO file that we'd like to use to test our libvirt installation. So we'll copy this ISO to var libvirt boot. That's where our ISOs belong, right? in the boot directory. All right, let me move this to the side here. And let me go ahead and look at all the apps. There's the virt-manager or virtual machine manager. Very nice. I'm going to type in my password and proceed. So QEMU KVM host is running. So I can connect to that and create a new virtual machine. We'll use local install media. So copy the ISO. We'll browse. So it's not under disk images, it's under installation media. There is our Fedora Silverblue ISO that we've just downloaded and copied over to the boot directory. So we'll use that. It auto-detected Fedora Silverblue 37 as the ISO. So that's good. Go forward. We'll leave the default 3 gigs of RAM, 2 CPUs. We'll leave that. It's fine for this quick test. So enable storage for this virtual machine. Yes, we want a drive, hard drive, right? So we'll select or create a custom storage because we have a special pool for virtual machine images. That will be under disk images, the disk image pool. And under volumes, we'll click plus to create our new storage unit to be used directly by a virtual machine, as it says. We'll call it blue-1. It's copy on write. QEMU copy on write 2 is the format. 20 gigs is fine. So we'll click finish, and we'll choose this volume. Again, good thing that we have copy on write disabled on the hosting file system. All right. We'll call this virtual machine blue-1 or blue1. And here you can, for example, check that your network selection, the default NAT is set up using DNS mask via DHCP. You can also click Customize Configuration before install here. So we're going to use a BIOS machine here. You've got a whole bunch of other options. We won't go into that in this quick tutorial. But if you'd like, instead of BIOS, you can do a UEFI virtual machine. You can select one of these, including the for AMD processors like this one or Intel, if you've got an Intel machine. I'm going to stick with BIOS today. Keep things as simple as possible. Yeah, you've got a lot of configuration items here, so we'll just stick. So let's boot the machine and begin installation. So as you can see, we're running a nested virtual machine inside this virtual machine on a Silverblue host. So quite a bit of nesting going on here. That's the power of KVM. All right, we'll just do a quick install here. I won't bore you with the details. Yeah, networking is functional, so it detected my time zone correctly. There's our 20 gig VDA that we've configured as a storage in the storage pool. Okay, and we'll just click Begin Installation. Very simple Silverblue install. We'll skip over much of this stuff so you guys won't get bored and tune away from this channel. So, yeah, it doesn't take too long, really. Yeah, configures the installed system, and it's complete. So let's reboot the system. And there you go. It goes into the welcome screen. So I just start setup. I'll just breeze through this stuff. Bore you with too many details here. Just want to show you that this works. So my username is Steven. I'll give myself a password quickly. Good enough. Click next. All done. Start using Fedora Linux, Silverblue flavor. Welcome to GNOME 43. We will skip over that, and there you go. Our virtual machine is running perfectly as far as I can tell. A virtual machine within a virtual machine, nested. I think that's awesome. So let's check the security for the virtual machine image itself with ls-z. var lib libvirt images, and blue-1.qcow2, which is our hard drive image for this running virtual machine. As you can see, svirt is enabled. What svirt does, the feature does, is it protects one virtual machine from the other. So all the virtual machines are protected from each other, and not one can go rogue and do something wrong with the other virtual machine. So security is configured well enough for me, and maybe for you as well. So now we are all done. Now you should be set for further configurations such as graphics pass-through for Linux gaming, running Windows or one of the BSDs, and so forth with near metal performance. I've been having great results so far, with flawless USB pass-through for my Windows-only hardware, including flashing device ROMs using Windows-exclusive tools. Thanks so much for watching, and if you found this tutorial useful, please smash the like button and subscribe. See you next time, and take care.